All right, so we are going to go over this last logarithm and exponential section. And we're going to first warm up by just evaluating a logarithm. So one thing to be aware of is what this says, and this is a kind of gross example, but this says 5 to what power makes 3. That's how you read this statement. 5 to what power makes 3. All right, so the thing is, well, 5 to the first power is 5. 5 squared is 25. 5 to the 0 power, anything to the 0 power is 1. So this is going to be a very ugly answer that we do require a calculator to evaluate. And there's this thing called the change of base rule, which essentially says we could just rewrite this as log of 3 divided by log of 5. Now, the idea is we've technically changed the base because here the base is 5, and the reason that's called the base is because we're saying 5 to what power is 3. So if the base is 5 and has an exponent of something, what is that something that gives you 3? Now we're changing these to read as technically 10 to what power is 3 divided by 10 to what power is 5. But, all that's there to say, your calculator doesn't necessarily have that little log with the bottom, so we can only do log of 3 divided by log of 5. We end up getting this crazy answer, 0.6826. I'm going to round that to 4 decimal places. All right, so that's just the change of base rule. If you've got a logarithm that actually has a written base, if it doesn't have an implied base of 10, the implied base of log is 10, and that's because it's even saying right there, 10 to what power? Log is telling you 10 to what power? ln is telling you e to some power. So that kind of information is right in the calculator. And then we move on to the solving section. And so we're going to talk about a very important rule of logarithms. Now there's some more algebra behind this, but essentially if you have a base, an exponent, and what I sometimes call an answer expression, you are allowed to convert that between a log with a base, an answer expression, and it will isolate the exponent. All right, now this is kind of a fancy way of saying this, but what this rule does is it transfers an exponent, which we can't isolate, into something back on the floor level, so to speak, where it's now isolated. So that's what this formula does. Now again, this formula reads the same way. If you kind of look at this, again, we were saying 5 to what exponent is 3. And so again, that's the other way of saying that. 5 to which exponent is 3. So that's that switch going on there. So I've got a base, I've got an exponent, and I've got an answer expression. So I'm going to switch this around. I'll have log of my base, my answer expression, and my exponent's all by itself. Well, now all I need to do is say, oh, that means I'm going to type log 11 divided by log of 4 in my calculator, and I'll have my answer. So log 11 divided by log 4 is 1.7297. Definitely getting some ugly answers there. All right, let's keep on going. You might think that all of our answers are going to come out as very, very crazy decimals. This one's going to be the first example to disprove that. But we've got a base. This time that base is a fraction, but that's okay. We'll take the entire fraction base to an exponent, and it's equal to an answer expression. So I'm going to rewrite that as log with my base, the answer expression, and I'm going to just write this on that side just to make that a little clean. So I'm just doing that same switch. I'm just changing where the equal sign is, but that doesn't change anything. Well, from there, I'm again going to do log of 32 divided by log of 1/2. You might be surprised at what this answer is. 1/2 is also 0.5. I get negative 5. I get a nice clean number, but it's negative. Now, why is that true? Let's just discuss that. Well, if you ever have anything to a negative exponent, all right, If it's like 2, then it's really 2 over 1. If it's 7, it's 7 over 1. So if you've got a negative exponent, you're allowed to flip that fraction and change the power. Well, now this is just 2 to the 5th over 1 to the 5th. Well, that's just 2 to the 5th, because 1 to the 5th is 1, and 2 to the 5th is 32. So that's why we're getting such a particular answer there. A lot of logarithm questions do have nice clean answers, just to make an extra one on the side here. If I say log of base 4, 64, some of you might know that 4 to the 3rd power is 64. So we don't need a calculator to evaluate this when it's a nice, easy, quote-unquote, power of my logarithm. So 4 cubed is 64. So log base 4, 16 evaluates to 3 because, again, this expression is saying 4 to what power is going to give you 64. All right, moving right along. One last exponential question. Now this one is a little bit different. There's one extra step, but ultimately I've got a base, an exponent, and an answer expression. So once again, I'm going to have a log with a base, an answer expression, and it's going to be equal to the exponent. Now this time the exponent had 2 pieces. Well, that's not too bad. We're still going to have to use that change of base rule. But now to get x by itself, I would have to subtract 4 afterwards. So that's what I'm going to type. Log of 13 divided by log of 5, and then minus 4. So I get negative 2.4063. All right, we're making great time. This is only a 6-minute video. Just imagine how long it takes in class, although I know we usually have questions during class. But hopefully you're following along. So now we've got 2 more questions here. 2 more questions. Yeah, these are going to be special. Now this time it's that we're starting with a logarithm, and our x is in some different places in our logarithm. So this time, it kind of works the same way, just in reverse. All these other questions, we had our x in the exponent, so we had to free it up somehow by using this rule. Well, now, if my x is in my logarithm expression, the only way to free it up is by using the rule in reverse. So the rule in reverse, let's just write that rule again, maybe in reverse actually. If I've got a base, an answer expression, and an exponent, I'm allowed to rewrite that as a base to the exponent and set that equal to the answer expression. Again, that's the rule that we're using. And why this works, we can get into a little later, but we're just going to take this as truth for right now. So we end up getting the base to the 2nd power is equal to x minus 1. And this is actually not that bad of a problem, because this problem just says, hey, 9 is x minus 1. Well, that just means that x is 10. All right? And I mean, that kind of makes sense. If we go back and plug 10 in here, if I plug 10 in, that says 9. So this says 3 to what power is 9? Well, the answer is 2. 3 to the 2nd power is 9. So 3 to what power is 9? Again, when you read the word log, you're kind of reading a logarithm like this. This to what power is that? And the to what power, somehow they write as log for some reason. All right, now we've got one more question here, and this one's definitely unique. This says x is the base, 4 is the exponent, and 625 is the answer expression. So we haven't quite done a problem like this yet either. So now my x is the base this time. So what to the 4th power is 625? And that just means what I need to do is I need to take the 4th root. The 4th root. Oops. 4th root of 625. That means I'm going to have x equals, and I want to show you 2 things here. Number 1, listen to that vocab. I'm taking the 4th root. So one way that I actually type in all these things is I don't use a root. If you hear that word 4th, that means it's really an exponent of 1 over 4. That's another way of taking a 4th root, an exponent of 1/4. But this calculator does have the ability to do that. If you press the math key and you scroll down to number 5, number 5 is saying some root, x root, your choice root. So I want the fourth root of 625. Now, the reason I've started doing this more is because if you end up taking calculus, this exponent rule ends up being more valuable to you to have memorized. And also, to me, it's like I'm not digging into a menu, selecting my correct answer. I'm just saying, okay, I know that I want the fourth root. Fourth is a fraction, so it's a fractional exponent. But it's your choice. So there is the last of the assignment in a 10-minute video. Hopefully you can try out those con assignments and get those in. But remember, this section, as far as the quiz is concerned, will only be extra credit questions. All right? Have a great day.